Hi, Aslam class. Welcome to your maths lesson today. Today's date is the 22nd of February, 2021. So before half term, we were looking at fractions. We're still going to be looking at fractions this week. Before the half term, we looked at equivalent fractions. We looked at non-unit and unit fractions. We also looked at adding fractions together as well, and what happens to a number when we to a fraction when we go above one whole. Today, we're going to still be looking at fractions, but we're going to go into more in depth into our subtraction of fractions. However, as always, the first thing that we need to do is to do our maths arithmetic questions. So on the screen, you can see today's arithmetic questions. You can pause the video now, and then we'll go through the answers once you're finished. So don't spend more than about 5 minutes on these, please. Okay, hopefully you've done a job on your questions. I'm going to stop sharing the screen so you can see the board behind me, and we can go through the answers together. So for question number 1, we have 8 times 7, which is 56. For question 2, we have half of 160. And what I do here, I divide that by 10, so I then get 16. Half of 16 is 8. Times that by 10 again, and you get 80. What is 46 as a Roman numeral? So it's 10 before 50 for 40. So XL, so that's the 40, and then the 6 is VI. So XLVI. Now this next one is a fraction. So what are 4 ninths plus 2 ninths? Remember, we don't add the denominators, we only add the numerators. So we get 6 over 9. Question 5, 6 times 7 is 42. Then we go over to question number 6. We get 16 divided by 8, which is 2. Question 7, write an equivalent fraction for 5 over 12. Now, all I'm going to do for this one is multiply the numerator and the denominator by 2. And that will give me 10 over 24. That is the equivalent to 5 over 12. You may have different ones, but that's an example of one of them. Question 8. 4,562 at 2,432. So we add the thousands together first to give us 6,000. Then we add the hundreds to give us 900. Then we add the tens to give us 90. And then we add the ones to give us 4. We're now going to take away. So we take away the thousands first to give us 5,000. Take away the hundreds to give us 500. We take away the tens to give us 50. And then we take away the ones to give us 4. And then for question number 10, 24 divided by 6 is equal to 4. So well done if you got all of them questions correct. Mark them, and then we're going to move on. Okay, so for today's lesson, let's start sharing the screen again. Okay, for today's lesson, we're going to be subtracting fractions that have the same denominator as each other. And today we're going to be looking at using number lines. But first of all, as a quick starter, which one of these is different? Okay, right, hopefully that's given you enough time to quite a tricky one there, but the correct answer is this one here, 5 and 5 eighths plus 5 eighths, because when you plus all the others together, and when you turn them into a mixed number, you'll always get it out of a half. So 1 whole and a half, and you can see in these pictures here, we've got 1 whole and a half, 1 whole and a half. 5 eighths plus 5 eighths gives you 10 over 8, and as a mixed number, that gives you 1 and 2 eighths. So it's 1 1/4, not 1 1/2. Well done if you got that one correct. Okay, so we're going to have a look at subtracting fractions in a little bit more detail. So in this question, Harry takes 2 identical strips of paper and he folds them into eighths. Explain how we can use these pieces of paper to find the answer to this subtraction. So what he can actually do is the following. Now, I haven't got a piece of paper with me, but you can do this at home if you want to. If you're at school, you may be able to do it I think I'll send a template over. It's on Tapestry on Teams as well, so you can look in the resource pages there as well. So we've got 2 identical strips of paper. We've got 12 eighths first. So let's color in 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's our 12 eighths. Now you can use these pieces of paper to subtract by simply cutting out 5 eighths, or you could just cross them off. So we got 1, 2, 3, 4, 5. We're now left with 7 eighths. So our answer is 7 over 8. So you can see there how you could use bits of paper, you could cut the strips off, or you can just colour them out. So there we go. And if you use a pencil, you can always rub it out and reuse the strips of paper again. So that's how you would subtract fractions using a piece of paper. Now, you can give it a go. Get 2 strips of paper, okay, and you fold them in half, okay, and then fold them into half again. And you'll then get your eighths, okay? And what you need to do is just give it a go answering these questions. So pause the video. Okay, welcome back, guys. We should now be able to see your answers. So let's see how well you've done. So for the first question, 6 eighths, take away 3 eighths. You should have got 3 eighths, and you can see here your strips of paper could have looked like this, okay? Your 9 eighths, take away 4 eighths, all right? So you would have had to have 1 whole here. You can see we've taken away 4, and we're now left with 5 eighths. And for the last one here, we had 14 eighths. So we had 1 whole and 6 colored in here. We've taken away 5. We still have 1 whole, and then we have 1 over 8 here. So as an improper fraction, that would be 9 over 8. Or if you wanted to have it as a mixed number, that would be 1, and then 1 over 8 next to it. Well done. Now you can also use bar models to subtract fractions as well. And you can see in this example, we started off with 10 over 6. So we've had to split our bar into 6 parts. We know we've got 1 whole of them because we've got an improper fraction. So we needed to do another one. Color in the numerators. So we've got 10 over 6. So we colored in 10 of our squares. We then cross out 5 of them. And what are we left with? 1, 2, 3, 4, 5. So 10 over 6 take away 5 over 6 is equal to 5 over 6. So we could also, so you can give this one a go, or I'll show you this one again, in fact, because you'll do next. So in this one here, we've got 9 over 8 take away 1 over 8. So here we go. We've colored in our 9. We've crossed out 1. And what are we left with? 8 over 8, or we're left with 1 whole. So the steps are, number 1, are to draw out your bars and cut them into equal parts that the denominator is required. Step 2, color in the numerator of the first fraction. So we've got 9. Then cross out the numerator of the second fraction. In this case, it's 1, and then count up what you're left with. And we're left with 8. So you can use bar models now to help subtract these fractions. Give it a go and see how well you do. Okay, welcome back. This is the, here are your answers. Okay, and your bar model should look a bit like this. So we've got 9 here, we've taken away 4, and we're left with 5 over 3. Over here, we've got 11 over 4, we've crossed out 3, and now we've got 8 over 4, or 2 whole. And this one may be difficult to see, but this is split up into 16. We've taken away 7 from 25, and that has left us with 18. So that's 18 over 16. We also see problems like this, and where you have to use your reasoning skills. Sam says 11 over 9, take away 7 over 9 is 4 over 9. What mistake has Sam made here? Well, it's very clear. He's actually taken away the denominator as well. And by doing that, he's changed this fraction into 4, well, into nothing. Because 4 over nothing is there's nothing there. How can you, 4 over nothing is nothing. You've got no denominator, you've got no bar or shape or whatever to cut into. So by taking away the denominator, you're actually getting rid of the whole value. So that's why the denominator has to stay the same when you take away. So here are your tasks for today. Question 1, pretty self-explanatory. Just answer them questions. Question 2, you've got another row of questions there. And in question 3, task 3 is your challenge. Now, you can pause the video so that you can answer your questions, and then we're going to go on to the answers. Remember, you should all be trying question 1 out first, and then push yourself to go on to question challenge 2 or 3. Okay, there we go. I'm going to quickly get up the screen for me so you can see what I'm doing for the answer. So question 1A, let's do question 1 first. Okay, it says 5/7 take away 3/7, and you can see on our bar here we've got 5/7. We are then going to take away 3, so we go 1, 2, 3, and we're left with 2/7. So that's your answer for question number 1. And for question B, you can also use the lines there. So for B, 7/4 takes away 7/9 take away 4/9 is 3 over 9. For C, 7 over 10 take away 3 over 10 is equal to 4 over 10. For D, we've got 6 over 6 take away 6 over 6. That would give us 0 over 6. For E, we've got 8 over 93 take away 2 over 93, which will give us 6 over 93. F, we've got 8 over 3 take away 4 over 3, which will give us 4 over 3. And then for G, we've got 9 over 5 take away 4 over 5, which will give us 5 over 5, or you could say that is 1. Okay, we're going to do the answers for question 2 now. So for question 2, part A, we've got to fill in the missing blanks. So what have we taken away to get to 7ths and 11ths? We've taken away 3 over 11. For question B, we've got 10 over 11, take away something, gives us 7 over 11, take away 4 over 11. 7 take away 4 is 3 over 11. So what do we take away from 10 to get 7 over 3 over 11? That's right, we take away 7 over 11. For question C, 15 over 4, take away something gives us an answer of 2 whole. Okay, so 2 whole. So what do we do to take, what have we done to give us 2 wholes? So 2 wholes, if it's out of 4, needs to be 8 over 4. So if we do 15 and we take away 7, we get 8. So 7 over 4. And then for part D, we got 11 over 4, take away 3 over 4. So 11 over 3, 11 take away 3 gives us 8. So we need to figure out what we need to do here. Now, the tricky part here is that our denominators are different. However, we're not taking away 3 4s against 11 3s. We need to get, so we know that 11 over 4 take away 3 over 4 is equal to 8 over 4. Now, we need to think of an equivalent fraction here to make sure we get this one right. What number is in the 4 and the 3 times table? Should have said 12. So let's times this whole fraction by 12. By 12? No, by 3. So then we get 24 over 12. Okay, so we're now looking for 2 wholes, aren't we? Yeah, so we know we're looking for 2 wholes. 11 over 3, take away something to give us 2 wholes. We're looking for something that gives us 6 over 3. All right, so what do? We take 11, take away, let's see, what do we take 11 away to get 6? Of course, it's 5. Yes, so it should be 11 over 3, take away 5 over 3, gives us 2 wholes as well. It's quite a tricky one there. Well done if you got that one correct. And for the last question, question number 3, Alex and Annie are taking turns playing a computer game. Annie plays a total of 2.25 hours. Annie plays for 3/4 of an hour more than Alex. How much do they spend in total playing on the game? So Annie has played for a total of 2.25 hours. Okay, Annie plays for 3/4 of an hour more than Alex. Okay, so what is 3/4 less of this? We need to find out that first. So this we can put here. This is what Annie is playing. Now, if we just turn this into an improper fraction first, so it's a little bit easier. So that is 4. That is 8. Oh, sorry, not 8. It's 9 over 4. Take away 3 over 4. 9 take away 3 is equal to 6 over 4. And that, as an improper fraction, is as a mixed number, sorry, is 1 2/4. Okay. So now we've worked out how much Alex has played for. Now the question actually says how much time do they spend in total. So now we need to add these two values together. So all we need to do, we can turn them into improper fractions if you want to. That may make it easier for you. Which is 15 over 4, and then that as a mixed number would be 3 3/4. So well done if you got that question correct. All right then guys, well done. I'll see you in the next video. Bye-bye.